Students, we have discussed 7 numericals from the section oscillations. Alright. Now we will discuss sum number 8. You can see the sum from the attachment also. Now let's discuss the sum number 8. Alright. Alright. So what is the question that I will dictate? At what displacement from the position of equilibrium will, question number 1, the velocity of a particle in SHM be half of its maximum velocity? And the second question is, its acceleration be half of its maximum acceleration. Understood? So we'll move part by part. Alright. So for question number 1, we can see that for a particle, first of all, question number 1 is what? That you have to find out the displacement from the position of equilibrium when the velocity of a particle in SHM be half of its maximum velocity. Alright. So yes, let's proceed. So for a particle in SHM, students, when its displacement from its equilibrium position is x, okay, then its velocity v equals to what? V equals to plus minus omega root a square minus x square. This is the case when a particle is undergoing the SHM and the displacement from its equilibrium position is x, that we usually denote, then its velocity will be this one. This is basically nothing. It is what the formula that you have read in the theory classes. All right. So if x equals to 0, all right, then the maximum velocity's value will be what? If x equals to 0, then v max will be equal to plus minus omega a. Why we are writing it, students, this particular equation? Since it's written that it is when the particle is undergoing SHM, its displacement from its equilibrium position is x. Now, if x equals to 0, then obviously your v max will be plus minus omega a. So we are considering this. Alright. So if you just go through the question, students, it's written that the velocity will be half of its maximum velocity. Alright. So what is the formula for velocity? This. Alright. So we are writing the equation statement, students. So by the problem, we can write omega root a square minus x square equals to omega a by 2, isn't it? Just we are writing it from the question itself. Alright. So just do the calculation. So this part is your maths part. Okay. So we can write it as a square minus x square equals to a square by 4. What we are doing it? We are just cancelling omega from the both side, from this side, and we are removing the root. This is your maths part. So I'm writing the final term, students. The x value will be equal to plus minus root 3 by 2a. Alright. Okay. So this is your required displacement, isn't it? You have to find out, just go through the questions once again. At what displacement from the equivalent position the velocity of the particle will be half of its maximum velocity? So at this displacement, that means when the particle will cover this much, then the velocity will be half of its maximum velocity. So this is your required thing. So first part is done. Okay. So now move to the second question, that you have to find out the displacement when its acceleration be half of its maximum acceleration. Okay. Now if you go through the theory portions once again, you will see that from the definition of SHM, the acceleration of the particle is directly proportional to the displacement, isn't it? If you just recall the theory, that we have come across this formula, that A is equals to minus omega square x. This is the basic formula in the SHM. So that means this your acceleration is directly proportional to the displacement. So we can say that, so when its displacement is one half of its maximum displacement, so the amplitude, that is the amplitude, then its acceleration is also half of its maximum acceleration, isn't it? I'm repeating once again. When your displacement is one half of its maximum displacement, that means we are talking about the amplitude part. So then it's your acceleration will also be half of its maximum acceleration, isn't it? Because they are directly proportional to each other, isn't it? So your second answer is also done, isn't it? That means your final answer will be, here we don't have to calculate also, just the statement that we have to write as I told you just now. All right? Okay. Now let's move on to the next sum, students. Okay. Your next sum is your question number 9. All right. That I'm dictating the question. The time displacement equation for SHM is given by x equal to a sine within bracket omega t plus theta. Now show that the velocity v and the acceleration a are related by one equation that you have to prove, that is omega square. You have to prove this. Okay, I'm writing in short as pt. That means prove that omega square v square plus a square equals to a square, that is your amplitude square, omega 4. All right, this is your acceleration, this is your amplitude. All right, so let's proceed like the conventional way. Okay, so your value of x is given, students. So you all know that you have to find out the value of v, that is dx by dt. What will be the value of dx by dt? It's a omega cos omega t plus theta, isn't it?